Okay, I think he gave a little bit more than I wanted to give about myself. Thank you. Yeah, so a little bit about who I am and where I come from is from data science, software development, and technologies, and especially Python. And I have background both in technology and in journalism, mainly working with languages and multi-languages, Arabic, Hebrew, Hindi, and of course a little bit of English. And my mission is, when I look at the processes, to make everything easy, quick, and not expensive. And so that's why I try to find tools that makes the job easier for everyone. So what I will cover here, I will cover the case of encoding open-ended questions and the challenges usually the industry face with by hand translation, outsourcing to other native speakers. And I will show some examples with traditional machine learning and with the AI side of things. So the case at the BBC, we faced is we do brand tracker survey. It has been running since 2017, and we asked a couple of open-ended questions. One of them, why do you use brand X? Reason 1, reason 2, reason 3, give us these reasons. And we allow people to write answers in at least 15 languages, some of them Arabic, Portuguese, Spanish, and English, and Russian, and Hindi, and all these languages. So that's caused a little bit of kind of the traditional model. We used to do it, we wait weeks or even months to get the answers encoded, and also we get them encoded in one level. So the team wanted them to be encoded in 3 levels, and these 3 levels the team thought should be we encode 1 level, we spend the same amount of work encoding the next level and 3rd level. And these are the levels. I hope maybe you can see a little bit of them. So say like someone says, I watch BBC because I like Liverpool. Some people say, I watch BBC to follow the cricket. And we say all of these are sport. This is the 2nd level. And then the 3rd level we say all of these are near news, so not a news, hard current affairs in news. And the same with a lot of things. So people will basically put about, like if you try to break them into subjects, like will be around 10,000 subjects. Everyone is watching the BBC for different reasons, or CNN, or Euronews, or other things. And this bring us a lot of challenges. The manual way, it has a lot of challenges, but even when you want to automate them, also you have a lot of challenges if you want to rely on keywords or kind of search, like programming, traditional programming. So you'll have the spelling errors in languages, empty answers, very short answers, meaningless answers, irrelevant answers. And also, you can't imagine how horrible people filling these open-ended questions. So I give you all kind of headache, like you find it. And the approaches, we talked about the classic approach. You translate from whatever other language, then you do it yourself, one workforce, or you outsource them, usually to some other place. But there's also like more, a little bit semi-automated kind of workflow to do them, which you can do with one kind of a provider, AWS SageMaker Ground Truth, which basically you put your answers in some repository, and the Amazon Web Services will send it to Mechanical Turk, which you pay for each encoded answer. Depends on how much you want to pay. You can specify. So I put here a little bit of how you do it and how much it will cost you. So say, for example, you have 1,000 answers, open-ended answers, and you want encoded with this one, basically humans working on some other places in Chile, in China, in Turkey, or other places. You can encode them. They will cost you around $1,000. But once you get, like, say you have 100,000, you will be more expensive for you. It will be more, like, this is one of the tricky points. Like 1,000 responded or 10,000 respondents will be cheap to do it with Amazon SageMaker Mechanical Turk. But once you get more, because Amazon charge you more for handling the data and running the workflow for you. And this method also, you can use Mechanical Turk, as you can see here, and you can use your private workforce. So, for example, if you have a big team, 20 people, for example, and you say, I don't want to pay that money, I want our team to do it, or maybe our team understand the data more than generic workforce, so you can do it. Or you can go with vendor managed, which basically like specialized companies, they say, who do like audio classification or kind of video classification. And you can say, I want these tasks to finish maybe in 2 days or something. And the price, you specify the price, basically kind of bidding. Say like who's willing to take this job. And also you can allow Amazon to use machine learning they have, what they call it active learning. So once the humans classify a few answers or encode a few answers, they can use these like labeled data on the active learning and run system on it, classify more, and then the things that they find or their algorithm find tricky, they will send it to humans. And also you can specify 3 people or 2 people or 1 person per label. So say this answer is about liking football. Other person say, no, this answer is about liking the British culture, for example. Or no, it's about the Premier League. So you can vote between them. So it gives you this capability, but you pay for the 3 people. So the problem with like this labeling workforce through AWS or Amazon Web Services or other providers, it can get expensive with large amount of data. There are a lot of hidden costs around the data management and things. And also it's when you send like a mixed data set, if you have like people answer the same survey in different languages, so I'm not sure if they can, if they send the language, so someone answered in Hindi, sending it to someone speaking Portuguese, for example. You can do with that, you can send like, sort the answer and filter them, split them for each population, Hindi or Portuguese. But also it needs some skills in cloud computing and AWS. Also you need someone who understands cloud computing, and you need to create an account there. So the other approaches, which is a classic machine learning, it's a mix of many different techniques. Using a pre-trained large language model that is multilingual, and then adapted with capabilities of to group these answers, basically topic modeling, but with like sophisticated topic modeling. So there are a lot of libraries in the Python ecosystem for doing that. I tried many of them. We tried many of them at work. One of the best I found to work with short answers is top2vic, so topic to vector. And the general workflow for this library is you have a pre-trained large language model that's very small, free, open source from Hugging Face, Transformers, anything. And then that pre-trained model usually has a step for tokenizing. Tokenizing is splitting just a word or maybe subwords or character level, or whatever you want to choose. And that also gives you some a little bit of processing with n-grams, like the words that comes together. New York is not 2 words, it's just 1 word. United States of America is just 1 word. So you can choose like 2 words or 3 words, how much you think your data has specific words for it. And then after you train the model on all your answers, basically you save the model, and then you can load the model later, and then you can even reduce the model. For example, the model could find 6,000 topics by default, for example. But then you can reduce it, say, I want only 100 topics. Maybe people liking BBC for the sport and for the news and for the weather and for something like, you make it shorter. And also then you can use that model to score or get the topic for a single answer or a group of answers if you want. I will go through the code for that later. But this one, first one, for example, you query the topics. The topics is the answer, and you tell me, like, give me what's the topic for this answer based on the model I trained. So it will go look at the model and say, okay, the closest answer to this text is topic number 1. And you know topic number 1, for example, it's about news. You decided topic after you looked at the words of it. Then the other one, you say, like, give me all answers that's about that people said we like BBC for presenters, for its presenters, for example. And I say, like, okay, give me all documents that mention these things. So then you can do more analysis on it. Or if you have the old survey or a new survey with all these answers, open-ended question, you say, like, okay, this is the IDs of them, and give me everything back. It's just like batch processing. And the advantage of and effectiveness of topic-to-vec, the Python library, I will show some code how to go through it. It's just a simple thing. So it's like pre-trained embedding. Embeddings here basically turning the text to numbers, but the turning of text to numbers has many different ways you can do that. And the pre-trained model is just give you the head start. And how good the model you have. For example, if it's multilingual, you will be able later to do on multi-language answers. If not, just English, you'll do on there. And also do some processing behind the scene for you, so you will not be doing a lot of text processing yourself. And also it will do dimensionality reduction with UMAP. So UMAP is like MDS dimension, multi-dimensional scaling, or BCA, or other things. Some of them works well with linear. BCA turns everything to a linear new space instead of X and Y, Cartesian space. This one works with non-linear spaces and like manifold learning. So it captures good relationship. And then you do HDB scan. HDB scan is like the clustering. We go back, like basically what we are doing. We are taking the text, converting it to arrays of numbers. Then we squishing them down. Instead of 100 dimension, we say, like, I want 100. I want 10 dimension. Then we clustering these dimension with HDB scan. And from that, basically, you have dense locations, and these points will say, like, okay, this is the topic. And what's the middle things? These kind of words. Say, like, okay, this topic is about this word. Maybe it's about a news. But as always, this method works out of the box very well, at least with the use case at the BBC, where we apply it to multi-international surveys with a lot of languages, with short and generic, because we ask people, like, why do you like BBC? You said you use the BBC, and everyone gives you a different reason. We ask, why do you like CNN? Very few people liked it, but they gave you thousands of reasons why they don't like it, for example. So that works. Another one done on the UK survey, it's specific about, I think, specific program about the BBC. So, like, it's very detailed about one subject. And that will goes about its color, its tone, it's the time of a broadcast, which is different a little bit. So it works out of the box well. Maybe you need to do more, but yeah. So other methods you can do and to get some insight from open-ended questions, word counts, word clouds, bag of words, clustering, LDA, latent, Dirichlet, allocation, or other one. But they don't solve the problem, and the reason they don't solve the problem, I put a lot of details here. So because all of these bag of words, all of these, they rely on absence or existence of a word in the answer. So they don't take into consideration the location of that word. Right? And also you'll have spelling mistakes, so each spelling mistake is a new different word. And you can say, okay, I can do a pre-processing step by correcting the spelling mistakes, but you have many languages and it get hideous. And also high dimensionality, so the vocabulary will be big because of the mistakes, spelling mistakes, and all languages. So you have different languages. So importante, important, muhim, everyone in these languages will be a different word. And it ignores the context and multilingual issues. The same goes with all these methods that rely on word counts or word existence or co-occurrence of words. Right? So that's the things. Same, you can, instead of word counts, you can do clustering and with TF, term frequency, inverse document frequency, which is basically just, if you look at it, it's kind of creating embedding, creating representation, vector numbers. Still suffer from the same problems. LDA, it's very interesting for topic modeling and grouping things, but the issue we faced here, like it's short answers and also multilingual. So LDA works with assumption of all documents coming from the same distribution, statistical distribution. But this here doesn't work because like Arabic and Portuguese is completely different distribution, the words in them. So that doesn't work. And also this one usually works with long sentences, long paragraphs, long documents, instead of like very short utterness of words like usual. So other approaches, zero-shot learning classification. So you take a pre-trained model, pipeline, and you use that as a classification. I will show an example of that next after this one. And also you can use a few-shot learning. And so for us, the 3 levels, it turns out we don't need to classify the answers in 3 levels. So once we classify first level, the lowest level, we can then just map them because we have them already specified. We say like Premier League, cricket, basketball, all these are sport. And then I have a map, a dictionary association between all this, map them to this. It's just a programming step. So we don't need to work on the 3 levels in the first time. So we used it quite a little bit at the BBC, and it's the beauty of it, like it doesn't take a long time, it doesn't take a lot of code, and I will go to the, so I will talk about the implication for that. So for example, now in our surveys, we ask people to write, and people, some of them just jumped on the keyboard, like started just fill whatever because they are not allowed to move there. So maybe in the future, instead of just responding by writing text, maybe they can record their voice because the method will work the same. You will go create vectors of the voices and then you go through the same steps. You will reduce the dimensionality of that, you cluster them with HDB scan, and then you use the same step. It's the same, but just the first step. Instead of word to vector, audio to vector, like you change this one step. And also you can use it with images, the same thing. Like if your use case asking people to upload images or something, how does this product makes you feel? Maybe show us how you can classify them, the same thing, cluster them. And also you can cluster the videos because nowadays in reality, even like Amazon, they have a method called object to vec. So you can object any object. You can do that. And this is, I think, will make user provide more relevant answers, more useful answers, because it's easier to speak your opinion more than write it in writing. So I will go to the code, show some Python code. So yeah, so the word-to-vec process now, which is kind of traditional machine learning, clever traditional machine learning, combining a few steps together. So basically all you have to do, you have an ID for the answer, and this is the answer. As you can see, some are in German, I think, one of them. And kind of this is the input. And you go all you have to do is just, this is the model input. So this is you train the model. So you have your documents and you have the pre-trained embedding model. You can use any embedding model if you want. OpenAI, you use OpenAI, Claude, or Anthropic, anyone you use. And then you have a few options about the HDB scan. and also the tokenizer, min count. So the words that are very rare, you are not going to care about, like any words that didn't come in the data set less than 10 times, for example, you don't need to worry about it. Topic merge delta, so this will affect how many topics you will get. This is because it goes to the HDB scan kind of the algorithm that's in the steps. And n-gram vocabulary, like if you want to use n-gram, not just like single words. And tokenizer, like use the tokenizer from the embedding model. And workers, that's run them in parallel, how many CPUs or GPUs you have in your computer. And the speed, like you have different levels. So deep learn, like learn as much as possible, take more time and processing and learn much as possible. And the size of the embedding of the batch also sometimes affected. This is kind of parameters for the neural network of the embedding model. Then you train the model, and you can you get the topics if you want, the word for each topic. This is just a sample. These are two rubbish topics found from our data set. And then like you get even the relevance for each word in that topic. And you get these numbers. Topic numbers, the numbers of the topics found, like topic number 0, number 1, and you go. Topic sizes, for example, the first topic has 863. And then once you train your model on all the data, you save that model. And once you have that model saved, you can give it to anyone, or you can use it anytime you like. You don't need to re-go through the training process. So you can load it. You load the model. Once you load the model, you want to learn what you can do with it. You can do these steps. Then also, like, if the original model you trained found 9,000 different topics, you can reduce it. And you say, like, OK, I want to reduce it to 50 topics. So that's the one other things. And you find the topic words and what other things you can do with the model. And this is how you, for example, how you score a new sentence, a new answer, a new topic if you want. Say, OK, which topic this sentence belongs to? Say to topic number 20. And you say, OK, I don't know what's topic number 20. What is it talking about? Say, like, OK, give you word cloud of that topic number 20. It's news in English, Harbler in Turkish, notices, I think, in Spanish or Portuguese. And you say, like, OK, this is about the news, because I said I love BBC News. I thought, like, I'm talking about the news. I watch BBC because I watch the news. And then another sentence, for example, tells you, like, also it's about number 20 and goes on. The other one, like, if you only want to score the original data set you input for the model, you can treat it as information retrieval, and information and will give you quick and easy solution back. You only get your topics. If you have a new one, you can score a new one. So that's one. One second, and I will, because the beautiful side here. Okay, so if you want like even easier pipeline, text generation, GPT-2 or 3 or whatever you can find on the internet from Hugging Face, and you say, okay, for example, this one, translate from English to French and translate it for you, and here tell me the sentiment of the following sentence with one word, either positive or negative. I am very happy to see you, says positive, as you can see. And tell me the sentiments, I like BBC, says positive. And here, tell me the sentence. Although I liked the BBC in the past, I stopped, and tells you it's negative. And the last one, reason, the zero shot. The zero shot even gives you more power, but it's the same simplicity. Like it gives you, like you treat it as a classification. I say I have two sentences. I want to classify them into these topics, these answers, and say, okay, this first one, politics, is about politics and the score 90. The other one is about Liverpool, Manchester. It's about sport and the score 97, and goes on. And this one, like the only things, if you like, all you need is just 4 lines of Python, free, quick. You don't need OpenAI or anything else. And yeah, thank you.
Thank you. Sorry, I could see them putting the food out, and I didn't want to get it cold. Have we got a question? I think, Jerome, your hand went up.
I got involved in text analytics before generative AI using correspondence analysis, which was invented by Ben Zekri just for that. I was happy to hear you talk about dimension reduction. Do you still use lemmatization and those old techniques to project words, or what do you do with advanced PCA and all those things?
Yeah, so basically, in this solution, they are using UMAP, which is nonlinear dimensionality reduction in manifold. So instead of linear, it's just multidimensional. But BCA in this case is not used. In this case, in this library, it's used in the vectors, in the embedding. After you have the embedding, so instead of you just get them smaller and smaller. And the reason they do that, I read their documentation, the reason they do that because in high dimensional space, the Euclidean distance or L2 or cosine, everything get distorted. Things get far away from each other. So they put it like they make it smaller in that case.
Hi, very simple question. What size of data sets do you use for top to vec? I mean, 10,000, 20, 100, 200?
This one around 8,000. Yeah, 8,000. But the things like it works because it relies on pre-trained model. So that's the things.
So my final one then. So if you go back to when you started doing this survey with the brand study, all of the work now, how much more efficient is the process than when you started?
I think it takes about now 5 minutes to do that, and not just that, because researcher will, for example, for me, I will do this and give them either the code. I tell them like this is how you run it. If you want to run it, there's just a few lines. You change just the input file, or I give them the output in Excel, and they will look at it. I will say, I don't like these kind of the topics. Can you rerun it again? It's a lot of topics, for example. So, like in a day, you can get away with finishing your open-ended question. But also, they come and ask more questions about text analysis. Like, okay, now you gave us like you basically grouped them. Can you give me the entities? Like they are talking about specific presenter, they don't like about the BBC, or are they like these kind of things? Then they say like, okay, what's the sentiment? Or how long the sentence? So they give them like more answers because they think, oh, okay, it's easy now to do it. Okay.
Thank you. Thank you, Mohamad.
Thank you.